What's going on, everybody? Today we're going to be reviewing some derivatives of logarithmic functions, and I want to get started with talking about the derivative of log b of x, giving that sort of formal definition and also a small proof that maybe gives a bit of intuition to it. I don't want to be too lengthy on the proof because that's not the point. I want to solve one or two problems that really show how to use it, but I think the proof is useful. So let's start off and let's just define exactly what it equals. So if we take the derivative of log b of x, that is defined as 1 over x ln b. And sorry if my b's kind of look like 6's. Probably could have chose a better letter, but. So let me give you a small proof that shows this, and then we'll move on and we'll do some problems. So a good thing to start with is we can let y equal log b of x. Okay? Now, according to the laws of logarithms, I could set b to the y, b raised to the left side, and b raised to the right side. And if you notice, if I raise b to the log b of x, that's going to cancel out the log and the b, and I'm going to be left with b to the y. Excuse me, let me rewrite that. B to the y equals x. So now we have b to the y equals x, but it doesn't seem very useful right now, but it will help soon. And we also, I'm going to draw that back up here in a different color. There's another formula I'm not going to prove, but you can take on my word, that the derivative of b to the x, again that's a b not a 6, is b to the x ln b. So in knowing this, what we can do is we can differentiate our current equation that we have implicitly with respect to x, and hopefully that should be able to give us the answer that we want. So if we apply this formula to b to the y here, we're going to have, if we implicitly differentiate, since it's b to the x, we would say we have b to the y times ln b and then whenever we do implicit differentiation, we also have to take the derivative of what we have at the top. So here, since we're taking the derivative of b to the y, we also have to take the derivative of y. So we're going to have a dy dx here. And that's all going to be equal to 1. So now what we can do is we can divide both sides by by ln x here, and that's going to yield the equation dy dx equal to 1 over b to the y ln b. You notice how we're getting kind of close to our initial equation up here, and what we can have to remember here is that b to the y is equal to x that we set right here. Therefore, we can rewrite this equation as dy dx equals 1 over x ln b. And to me, that's a very important proof, because it really shows the fundamentals, and it's not a very in-depth proof that really shows you how the derivative works. And I really suggest when you learn a new rule like this, you don't take it for its word, and you actually solve the proof, because it really gives a lot of intuition and it helps you. So let me go ahead, and then based on some of the other problems we're going to do, let me write right here. I'm not going to do the proof because this one is actually kind of a lengthy proof. This is the derivative of ln x, and that's equal to 1 over x. Really, the proof of this is the proof of ln of x is really worth a whole video's worth of time. And I probably will do that. But let's do a couple problems. I'm going to clear off the board, and then I want to actually do a couple problems so that we can get accustomed to using that. So let's start off and let's just do a logarithm problem. I think we're just going to do 2 problems here today because I don't want the video to be too long. So we're going to say we have log 10 of 1 plus cosine of x. Okay, so if we want to take f prime of this, we remember from the formula that we just learned that d dx of log a of x, just write it down here, is 1 over x ln a. So let's go back and let's solve this then. We have f prime of x equal to, and then if we just follow our formula here, if we know that 1's going to be on the top, we can go ahead and write that. We know our x is going to be equal to 1 plus cosine x. So we have a 1 plus cosine x here. And we also then have to multiply by our ln a, which is just going to be ln 10. The important thing to remember here is that you have to remember when you're using the logarithm function that this is a chain rule derivative, because you're taking really the derivative of the outside, but you can't forget to also take the derivative of the inside. So whenever you take the derivative of the inside here, you're going to be taking the derivative of 1 plus cosine of x. And whenever you do that, you're going to get to use our sum rule. The sum rule allows you, whenever you're adding 2 things and you want to take the derivative of both of them, you can just split that up and take the derivative of each separately. So here, if I want to write that out, keeping in mind that we still have this function right here we're not going to forget about, and this is going to be multiplied by that. I'm just going to pull it down here. 1 plus cosine x, we know that the derivative of 1 with respect to x, that's going to be equal to 0. So it's 0 plus the derivative of cosine of x with respect to x. And then the derivative of cosine of x, we all know, or should know, is negative sine of x. And you have to remember, it's important too, that if this was cosine of, let's say for instance, cosine of 2x, I would have had to then do the chain rule again. But in this case I don't, so my final answer, I'll write down here. Remember that this is being multiplied by that right there. So our final answer is going to be negative sine of x over 1 plus cosine of x ln 10. And that's a pretty fun little exercise, and it's a good one to practice. Okay, let's do one that's a simple one with ln, because I didn't talk much about that. Like I said, I want to make this a kind of a shorter video. And I know it's been going on for quite some time. If you're still with us, then congratulations, you've made it. So here we're going to do the derivative of sine of ln of x. So also we have to remember here that, remember there's parentheses around that x, so if there was a 2x on the inside, then we have to do multiple chain rules, but here we only have to do 2. I guess technically really 1. So what we're going to do here is remember the chain rule that we have here. Let me go ahead and change that color back. The chain rule that we have here, we have to remember that we have to take the derivative of the outside and then take the derivative of the inside multiplied by that. But you have to keep the original inside the first time, and you'll see what I mean in a second. And most of you probably already know this. But it gets a little weird with logarithms sometimes. It trips people up. So here we have sine of ln of x. So the derivative of sine is cosine. And remember, we can't remove this ln of x because the first time around we're just taking the derivative of the outside function. We're not even thinking about what's inside the parentheses. But now that we've done that, we see down here in the formula we need to take g prime of x. And g prime of x is our ln. So we need to multiply this by 1 over x. Okay? So in doing so, since 1 over x is the derivative of ln of x, our final answer is f prime of x is equal to cosine of ln of x over x. And that's all there is to it. So hopefully in the future videos, maybe we can do some more proofs and do some more problems, but for now, keep practicing on these logarithms and work on your formulas. And like I said, do those proofs if you can, because it'll really help out.